Number 1 talks about a washer. It gives us the inner diameter is 1/4 of an inch and the outer diameter is 3/4 of an inch, and the washer is 1/4 of an inch thick. The density of the metal is 0.285 pounds per cubic inch. We have 5 washers and we want to know how much they weigh. So remember that you learned that the density equals the volume divided, or sorry, the mass divided by the volume. And so we're looking for the mass in this case. So we could just multiply V to both sides. So really we're going to be doing the volume times the density, and that's going to give us the mass. So we want to find the actual volume of this washer. So this washer is like a cylinder, just with a cylinder missing in the middle. So remember that the diameter all the way across here was 3/4 of an inch. And so if we found the radius, so if the diameter is 3/4 of an inch, then the radius is going to be half of that, which is going to be 3/8 of an inch. And you can certainly do that in decimal form. So you could do 0.75 divided by 2 and get your radius for that larger circle, or for the outer part, to be 0.375. So then we're going to want to find the area of that. And the area formula is pi times the radius squared. So we're going to do pi times the 0.375 squared. And then you're trying to do volume. So remember, volume is area of the base times the height. So we're then just going to multiply this by the height of the cylinder. And the height of the cylinder, or the thickness of this washer, is 1/4 of an inch. So then we'll multiply this by 0.25 to get our volume. So we're doing area of the base times that height. So then the volume filled in, so the volume of this whole cylinder right here is going to be 0.25 times pi times 0.375 squared. And that's going to give us a volume of 0.110446. So I'll just put to 4 decimal places. So that's if we had just a filled in washer. Okay, so just a whole thing, no hole in the middle. So then we want to find the volume of this piece that we're taking out. So the radius, or the diameter here, was 0.25. And so again, we'll divide this by 2 to get the radius of that inner part, and that's going to be 0.125. So we'll go ahead and find the volume of that cylinder. Okay, again, first finding the area of the base, and the area of your base is pi times your radius, 0.125 squared. And then the height of this, or the thickness of the washer, is still 0.25. So we'll multiply this out, and that will give us a volume of 0.0123 for that inner part. So then the total volume of our cylinder, okay, or of our washer, so the volume of the washer, you need to subtract these. So we need to take that blue number here. So this one is as if it was filled in. And then we need to subtract out this inner portion, okay, or this purple amount, to get our total volume for this washer. And when we subtract those, we'll get 0.098. And so now this is the volume of each washer. So then remember, for the mass, or the weight of the washer, we have to multiply it by its density. And then also remember that we have 5 washers here. So this is for one washer. So we're going to multiply this by 5 to get the volume of 5 washers. So 0.098 times 5 gives us 0.49 for the volume of 5 washers. And then we'll take this times the density, and the density per washer is 0.285. So we'll multiply this by 0.285. And that gives us a mass or a weight of 0.14 grams or pounds, 0.14 pounds. This was in pounds. Number 2, assume that a cell is a sphere with a radius of 10 to the negative 3 centimeters and that a cell's density is 1.1 grams per cubic centimeter. Koalas weigh 6 kilograms on average. So let's figure out how many cells are in the koala. So we need to figure out the mass of this cell so that we can divide the koala's mass by the cell mass to figure out how many cells there are. And so let's go ahead and figure it out for the cell. So again, volume or density equals mass divided by volume. So we're going to need the volume. We already have the density, and that's going to help us get the mass. So again, density times volume equals the mass. So let's figure out the volume of a cell. Okay, so a volume of a sphere is 4/3 times pi times the radius, which is 10 to the negative 3 in this case, cubed. And so I'm going to leave, this is going to be a really small number, so I'm going to leave it in scientific notation. So I'm going to do 4/3 times pi, and 4/3 times pi is 4.18879. And then we have this 10 to the negative 9. So 10 to the negative third to the third would be 10 to the negative 9th. This is the volume of your cell. And then the density of the cell is 1.1 grams per cubic centimeter. So if we multiply this 4.18879, the volume of the cell, times its density, that'll give us the mass. Okay, so the mass of the cell is what we're looking at here. So take this number and multiply it by the 1.1. So when we multiply 4.18879 times 1.1, we get the mass of the cell to be 4.61 times 10 to the negative 9. So this is the mass of our cell. So now we'll be able to divide these masses by the mass of the cell, and that'll tell us how many cells fit into each of these animals. So remember that this one is in grams, and here we're in kilograms. So 6 kilograms in grams would be 6,000. And I'm going to leave it in scientific notation. So this is really 6 times 10 to the third grams. Okay, that's a different way to write 6,000. So now we'll take and we'll divide this koala's mass by 4.61 times 10 to the negative 9th. So what we're going to do here is we're going to divide the numbers. Okay, so we're going to divide this 6 by 4.61. So 6 divided by 4.61 is about 1.3. And then we have 10 to the third divided by 10 to the negative 9. And so when you divide powers of the same base, you subtract their exponents. So 3 minus a negative 9 is 12. Okay, so this will really be 1.3 times 10 to the 12th. And that's just a really large number. So that's going to move this decimal 12 times. So that's really going to be 1. And then here's moving it 1 time, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is approximately how many cells this koala has. So this is thousands millions, billions, so 1.3 trillion cells. So then for this one, we've got 1400. So now this one's already in kilograms. So I'm just going to do this one as 14 times 10 to the second. So I'm just going to take off 2 of the zeros as 10 to the second. Then divide this by the mass again, which was 4.61 times 10. And this is kilograms. So this is going to be, let me redo this. This is not going to be a 2. So this is 1400 kilograms. And so then to turn it into grams, we need to add 3 more zeros. So then that's 1.4 million grams. So now I'm just going to take off all these zeros. So I'm just going to leave it as 14 times 10 to the 5th, just because it's such a big number. So now we're going to do the same thing here. We're going to divide 14 by the 4.61. So 14 divided by 4.61 is about 3.03. And then when we do 10 to the 5th divided by 10 to the negative 9th, so 5 minus negative 9 gives you 14. So this one will be 3.03 times 10 to the 14th cells. And then again, you could write it out. So then we'll move the decimal place. So here's moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times. So then this is how many cells would fit in a hippo, or how many cells there are in a hippo. Number 3, the density of water is 1 gram per cubic centimeter. An object floats in the water if its density is less than the water's density. And then it sinks if it's greater. So will a toy in the shape of a rectangular prism that's 1 by 2 by 2 with a mass of 3 grams sink or float? So we need to figure out its density. So we're going to need its volume. And so here's just a quick picture of it. And so it's going to be like a 2 by 2 by 1. So you just multiply all those together for a rectangular pyramid, or a rectangular prism's volume. So 2 times 2 is 4, times 1 is 4. So this one has a volume of 4 centimeters cubed. And remember, it told us its mass is 3. So then the density is equal to the mass divided by the volume. And this is a density of 0.75, which is less than water's density of 1. So this one's going to float. Number 4, a cube and a sphere both have volume of 512 cubic units. Which one has a greater surface area? So let's go ahead and take the cube, figure out one of its lengths, and then figure out its surface area. So for the cube, to get the length, you can just cube root the 512 since they're all the same. So the cube root of 512 is 8. So each of these lengths on the cube is going to be 8. So then to find the surface area, you would just take 8 times 8 gives you that one surface's area is 64 square units. And then a cube has 6 surfaces. So the cube's surface area is going to be 64 times 6, which is 384 units squared. So then we'll want to do a similar thing for the sphere. So now the volume formula for a sphere is a little bit more complicated. So it's 4/3 times pi times the radius cubed. So we know that the volume is 512. So now we're just going to need to work this formula backwards. So we're going to multiply both sides by 3/4 to cancel out that 4/3. So 3/4 of 512 is 384. So we get 384 equals pi times our radius cubed. So we'll divide by pi. And when we do 384 divided by pi, we get about 122.23. and that's our radius cubed. So now we will cube root this to figure out our radius. And so when we cube root that, we get our radius is about 4.96. So then we would take this and we would put it into the surface area formula for a sphere. And the surface area of a sphere is 4 times pi times our radius, 4.96 squared. And so when you multiply all that out, so 4 times pi times 4.96 squared, you get about 309 units squared. So the cube has a greater surface area. Number 5, give the dimensions of 2 solids with equal surface area and different volume. So you can, it's any 2 solids, so you can do whatever you want. I'm just going to do 2 rectangular prisms. So I'm just going to make up some dimensions here. So I'm going to start with a base of 10 by 2, and then I'll do a height of 3. So then this will give me a volume of 10 times 2 is 20, times 3 is 60 units cubed. And then for the surface area, we're going to have 2 surfaces that are this size, which are 10 by 3. So 2 30s. So I'm going to have 30 plus 30. And then I'm going to have 2 of these surfaces, top and bottom, that are 10 by 2. So those are each 20. And then I'm going to have 2 of these surfaces here, which are 2 by 3. So those are each 6. And so this is going to give me a total surface area of 112 units squared. So then I just need to create another one that has the same volume but has a different surface area. So I'm going to leave the height at 3. So I know I still need my base to be 20. So I'm just going to change the dimensions to 4 by 5. So 4 times 5 times 3 still gives me a volume of 60 units cubed. But now the surface area will change. So I've got 2 of these surfaces, which are 4 by 3. So that's 12 plus 12. Then we have this surface, which is 5 by 3. So we're going to have 2 of those. So 2 15s. And then our base, top and bottom, are going to be 4 by 5. So those are going to be 20s. And so if I add all of those up, I will end up with a surface area here of 94. Number 6, a right cone with a base that has a diameter of 10 units, and then the volume of the cone is 100 pi cubic units. What's the length of the segment drawn from the apex to the edge of the circular base? So let's get a picture drawn of this. So we know that this radius is 5 since the diameter was 10. So we can figure out the base area here is going to be pi times that radius squared. And they're leaving it in terms of pi. So I'm just going to put this base area as 25 pi. Then they're telling us that the volume is equal to 100 pi. And remember, for a cone, the volume is area of the base times the height divided by 3. So let's multiply by 3 first. To get 300 pi will equal our base area times our height. And then we know the base area is 25 pi. So we can just divide by 25 pi to figure out the actual height here. And so 300 divided by 25 gives us 12 since those pi's cancel out. So our height here is 12. Now they wanted the length of the segment that runs from the apex down the side. So now we're going to have to do the Pythagorean theorem here to figure out this length. So the hypotenuse squared equals the 2 legs squared and added together. So then this is going to be 144 plus 25, which is 169. And then we'll square root that and we get 13. All right, number 7, a pyramid has a height of 4 inches and a volume of 40. Select all figures that could be the base. So remember, a pyramid has a volume of 1/3 times the area of the base times the height. So I like to work this backwards. So we're at 40 equals 1/3 times the area of the base times 4, which is our height. So let's multiply both sides by 3 to get rid of that 1/3. And then let's divide by 4 to figure out that the base area needs to be 30. So if our base area is 30, that will give us a volume of 40 cubic units. So this rectangle, 5 times 2 is 10, so this is not going to work. 3 times 10 is 30, so this one would give us 30 units squared for the base area. Triangle, you do base times height divided by 2, so 10 times 30, or 10 times 3 is 30, divided by 2 is 15, so this one wouldn't. A right triangle with one side is 5 inches and the hypotenuse is 13. Well, this is the same triangle we just did on the last problem with 5 and 13 here. So if you remember, the other side was 12. So then we know that that's 12. So 5 times 12 divided by 2 for the area. Well, 5 times 2 is 60, divided by 2 is 30, so this one will be good. And then a heart-shaped, or a heart that has an area of 30, that'll be good. Number 8, select all solids where the formula area of the base times the height applies for the volume. So a prism, yes. A pyramid, no, because this will be divided by 3 since it goes to a point. So no for the pyramid, yes for the prism, no for the cone, yes for the cylinder. Number 9, 2 distinct lines L and M are each perpendicular to the same line N. So if I draw N, okay, line L needs to be perpendicular to it, and line M needs to be perpendicular to it. A fourth distinct line, distinct just meaning different, so not on any of these. Line K is also perpendicular to N. Does K intersect these other 2 lines? And explain how you know. And the answer would be no, because if it's perpendicular to N, then it's parallel to these. Okay, so L is parallel to M is parallel to K because they are all perpendicular to the same line. So that's a property that lines that are perpendicular to the same line are parallel to each other. Another way you might have explained that is that corresponding angles are all 90. So M is parallel to K because corresponding angles are equal. L is parallel to M because corresponding angles are equal. So they're all parallel to each other. So that could be another way you explain it.